Okay, welcome to another Orbiter 2010 video. And in this video, I'm going to complete challenge number 3. This is one of the default scenarios that comes with Orbiter 2010. It's located in the 2010 subfolder, and then in there's a challenges subfolder. I already did challenge number 1 and challenge number 2, so now we're going to do number 3. Now this challenge, according to the little bit of text that you see when you click on a scenario, it's actually the same challenge as number 2, but the difference here is that we are much farther out of plane with the moon. In the challenge number 2, you are only, I think it was like 3 point some degrees out of plane. I think that's actually enough that it still requires an off-plane transfer, but maybe it doesn't. Nevertheless, in this challenge, we're definitely so far out of plane that we definitely want to do an off-plane transfer. So one way that you could complete challenge number 2, and I think probably what, if you're very new to Orbiter, probably what you would do is you could go around to the descending node or the ascending node, whichever one comes first, and then do a burn to bring your relative inclination down to 0. And then from there transfer to the moon. In this scenario, you definitely don't want to do that, since the idea here is to minimize the amount of fuel that we're using. So if we went around to the descending node and did a plane transfer to get into alignment with the moon, we would use just a tremendous amount of fuel. So obviously we're not going to do that. Let's bring up TransX. Bring it up on both sides. We're going to target the moon. And we'll go forward on this side and view the encounter. So we are here, or rather I should say the moon is here, and we're going to cross a node here. We could transfer to the moon like that if we wanted, but if we did, we would have to do a very quick transfer to the moon. And we're not are we trying to save time here or anything? No, we're just trying to save fuel. So if we wanted to go to the moon here, that would be like a, I don't know, maybe 24 hours, 36 hours. It would be pretty quick. It would cost us quite a bit of extra fuel. So what we're going to do instead is we're going to warp time forward, and we're going to come around. We're going to wait until the moon comes all the way around to about here. And then what we'll do is we'll do our transfer at that point, because then by the time the moon gets over to this part of the line of nodes, we'll have adequate time to do a normal low energy transfer, or at least as low energy as is possible. So before we do anything at all, let's just warp time forward ahead. We're going to go at least this far. So let's go out to 10,000. Let's go to 100,000. It's going to take a while, so we've got several days to go. So here at this point, we're basically at a 90-degree angle with the line of nodes. So that's about 7 days between this point and that point. So we want to cut that in about half. So right about, like right there, maybe. Well, we might go a little bit shorter than that just to make sure that we don't overshoot the time. So that's going to be good enough. So now we can set up our off-plane transfer to the moon. View over to maneuver mode on, put in the normal amount of prograde. It's going to be 3100, something like that. Now variable over to the date, and we'll go backwards, it'll be faster. Now we're going to move time forward, so plus, and we have to bring this over toward the line of nodes. And you can see there we are, if we leave in one orbit, we're basically exactly where we need to be. So we got timed that out pretty well. You can see that has us all the way out to the moon. Okay, now let's, since I don't remember from number 2, let's go to orbit. Let's reference the moon. And let's target the Luna wheel. So it has an inclination of 44 degrees. Is that right? I thought it was like equatorial. For some reason that doesn't sound right to me, but let me check. Let's reference the moon, and let's target Luna wheel. No, I guess that's right. Huh. I wonder if between this scenario and number 2, if the Luna is in a different orbit, because I could have swore it was equatorial last time. I'll have to go back and check on that. So anyway, we want to check on that so that we can kind of start thinking ahead as to how we want to arrive at the moon. You know, do we want to arrive more equatorial? Do we want to arrive at an angle? How do we want to arrive at the moon? So by taking a look now, we can kind of start thinking ahead on that. Okay, let's look at orbit MFD. Actually, let me think about this for just a second. Because when I come back from the moon and go to Earth, if I want to go to the ISS, I can actually target it directly. Well, I'll think about it more on my way to the moon. Nevertheless, according to TransX at the moment, we're going to arrive with an inclination of about 35.35. It's not going to be really accurate, but we can kind of start thinking about, you know, maybe doing a bit of adjustments as necessary to maybe change our arrival inclination a little bit. So that's out to 39. So that's about 44. That's the correct inclination, but it'll change a bit. But let's check that one more time. What was it? 44.1. But I don't want to have my minimum altitude quite that low because TransX lies. So let's go to outward and just put in a touch of outward one way or the other. Okay, so a little bit of positive outward. That helps bring the minimum altitude out. And then I'll do a bit of an adjustment here with plane or prograde. To bring the inclination down. So something like that would be really good. So the inclination is exactly correct. It won't hold, and the minimum altitude is about 418. And we know that as we go out toward the moon, that this is going to change. There's actually a way to use IMFD, so you can basically do a one burn solution to go all the way out to the moon and have everything be correct, but I still have to learn how to use IMFD. So let's go ahead and do this burn. View over to target, and we're going to warp time forward to get closer to the time to burn. If I don't cough in the meantime. And when we get down to 300-400 seconds, it's always a good idea to come out of time warp and switch back over to view maneuver, go to the update variable and hit update, and just watch this information before I hit update. So it says the minimum altitude's 437, and now we're showing the inclination 43, but when I hit plus, you can see things change a little bit. Now, since I only had to go forward by a couple of thousand seconds, things didn't change too much, but when you warp time forward by 5, 10, 20,000 seconds, especially if you have to go forward by a day or more, then all of your TransX planning, it just won't be that accurate. So when you get closer to the time to actually do the maneuver, you definitely want to come to maneuver and do an update. Let's go to target.
Translation.
And we're going to basically be going prograde, so let's be lazy and hit the prograde autopilot for now. Get our vessel lined up. And once everything is centered up, we'll fast forward time to do the burn. Go ahead and leave prograde on just because I only have a few seconds here of time warp. Okay, we're really close to that point, so let's go out to real time.
Translation, rotation.
And let's rotate the vessel to the green X. And I'll just do the burn manually. I didn't leave myself enough time to set up a burn time calculator. So we're going to do the burn in 5 seconds. 2, 1, and we're burning. What would be cool would be if you could actually bring up burn time calculator in like these modes. It has time to periapsis, time to apoapsis, and the last mode is time to manual start. It would be cool if you could have a mode that would be time to TransX begin burn, and then have it inherit that number or that countdown. So you could base, and even actually it would be cool if it could inherit the velocity as well, because whenever it says, 3.1k, for example, that 3.1k is not exactly 3.1k. It's like this doesn't show all the decimal points basically. So it'd be cool if you could have the mode that would inherit the begin burn time and the delta V, and then you would just arm it or whatever. You have to push over here, and then when it comes time to do the TransX burn, you still have to center the green X, but otherwise it would start the burn on time and then stop it. That would be cool. Time warp forward, get through this couple thousand worth of delta V. And back off time warp here in a second. Center up our green X a little bit better. And reduce main engines here when we get a little bit lower on the delta V. Did I overshoot by 3?
Rotation.
Was I not paying attention that much? Okay, no, I still have 3 left.
Rotation. Translation. Rotation.
Okay, maneuver mode off. And let's bring up TransX on this side so we can view the encounter, see how we're doing. And we'll do a little bit more translation. That minimum altitude's a bit high, and our inclination's not quite where I want it. So if I just tap translation a little bit forward, then I would say that's good enough right there. Alright, now we're going to fast forward time till we get at least out to the halfway point, to the point where Earth is no longer the strongest gravitational source. And I hope I don't get any external noises. It's really nice here today, so I've got the doors and windows opened up. So hopefully there aren't any dogs barking or cars driving down the road or anything like that. I live on a pretty quiet street, but feels like spring here in Florida. It's really, really nice out. I should be outside doing something. Gravitational influence of the Earth is almost down to the point where it's a weak source of gravity. Now it is. And once that happens, TransX updates a bit and we have some more reliable information to go by. So according to TransX, we are going to arrive with an altitude of 1,100 kilometers. Of course, that's not quite right. So let's actually just warp time forward a little bit at 100 and see what's happening with this number. Okay, currently it says it's going up and the inclination is going down. So let's do a mid-course correction here. Bring up TransX over here. We're going to go ahead and turn maneuver mode on. And let's see what our variables do as far as affecting the inclination and everything. So that's taking the inclination up closer to 44, which is what we need, and it's bringing the minimum altitude down. I think it was 44.1. Let's reference the moon. Target the space station. 44.13. How could it possibly have changed? That's weird. Anyway. So a little bit more prograde here. It's bringing down the minimum altitude, and that's also what I want. And we'll go with that because I don't know at this point how much the altitude is going to be affected, so we'll just kind of set the inclination. And let's rotate. Now, somebody told me that with this sphere, you can tell which way to rotate, because if the X is at the top, okay, if you are facing, if your orientation of your vessel is heads up, at least this is how I understood it, so let me check. So first of all, let me go heads up. And get level with the center thing here. Now, since this X is here, that means I need to rotate to the right, and I need to pitch down. That's what I understood. And actually, I know that would be true because it's going to be a prograde burn basically. I do not understand that. That is, it's like it's always exactly backwards. You would think at some point I would get it right, but so weird. I guess I was right, I just didn't go around far enough. Anyway, so I've got the green X centered up now. Again, we don't have to worry about the timing because we are in between bodies, and there's a long way between us and the moon, so a matter of 2, 3, 4, 5 minutes on these types of burns just doesn't matter. But what I like to do is to go to the maneuver and reset the date. That just makes sure that everything's right now, this very second, and we can see that things weren't really impacted. Okay, now just a little bit of a burn here. We only got 4 meters a second to go.
Translation.
And I overshot that just a tad. Okay, view over to maneuver and off. And now let's warp time forward again, get closer to the moon. Keeping an eye on our inclination here. Try to arrive at the moon in plane. Actually, out of curiosity, something else I might be able to do. If I do an adjustment on that side and go Luna, is it just B1? Luna B01? I forgot what it's called. Luna OB1. Okay, so in stage 2, ships Luna OB1. Might be able to use TransX to help us plan this out a little bit better so that we can arrive at the moon not only in plane with the space station, but we could actually time it so that we arrive right next to it. I've done that before, coming back from the moon and just going straight to the ISS so that you don't get in orbit first. You just go straight to it. It's a pretty neat trick. Okay, so VW. Let's look at setup. Let's go to graph projection and change that to focus, and let's look at scale to view target. Okay, so according to TransX, we're going to arrive at the moon, and we'll be 3,350 kilometers away from the Luna wheel, but that's just terribly unreliable at this point. But let's see if we can do a maneuver to figure out how to fix that a bit. Just bear with me for a moment while I think about things. I'm thinking that this is showing that I'm currently, well, I am currently out of plane. But with an additional 4 meters a second, that shows where I will be. Let me go to view, setup, and view different graph projection. Let me do plan. View, maneuver. Change plane. See what what I'm expecting to see is this blue ring, which represents the orbit of the Luna wheel. I want to see it wrapped around the moon. And that's not happening, and I'm not entirely sure why. So let me reset plane change. Okay, so that has us within 1,000 kilometers of okay. And now prograde. Okay, that has me right there next to the Luna wheel, but we're definitely gonna, the timing on this one's going to matter, so let me reset the date and let's bump it forward so we can do this maneuver in like 5 minutes. So instead of 3050, we'll do it at 3100. Actually, that's good enough there. Okay, just a little bit more on the prograde. Has us down to 19 kilometers there. We'll go with that because I don't really think this will hold well enough for it to matter to get down to just 1 or 2 kilometers at this point. So let me go ahead and do this maneuver. Why is that so long ago? Okay, let me go back to date. I have this in the future, so, it might be because we're in a different stage or something. I'm not sure. Let's just do the maneuver. So since I'm heads up and the green X is over there, I should have to rotate left. I guess so. Okay. I'll bring the X up a little bit. And I'm going to do the burn now. So 24 meters a second. And after this burn's complete and we get everything checked out, I'm going to go ahead and end this part of the video since it's coming up on a half hour. Kind of thought I'd actually be able to complete the whole mission, but halfway out I decided I wanted to try to catch the Luna wheel when I arrive at the moon. Instead of getting into orbit and doing all that first, it'll be better if I can just catch it as soon as I show up there. So let me turn maneuver mode off. And let's just
Translation.
a little bit of translation. You can see that's bringing the closest approach down. A little bit of up-down translation. A little bit of lateral. And I think we'll go with that for now. Okay, so let me pause the simulation. If you like this part of the video, please hit the like button down below, leave a comment, subscribe to the channel if you're not already subscribed, and look for a link to my Facebook page down in the description below. And I will see you in the next part, which I'm going to record right now. Or the ascending node, whichever one comes first. And then do a burn to bring your relative inclination down to 0, and then from there transfer to the moon. In this scenario, you definitely don't want to do that, since the idea here is to minimize the amount of fuel that we're using. So if we went around to the descending node and did a plane transfer to get into alignment with the moon, we would use just a tremendous amount of fuel. So obviously we're not going to do that. Let's bring up TransX. Bring it up on both sides. We're going to target the moon. And we'll go forward on this side and view the encounter. So we are here, or rather I should say the moon is here, and we're going to cross a node here. We could transfer to the moon like that if we wanted, but if we did, we would have to do a very quick transfer to the moon. And we're not are we trying to save time here or anything? No, we're just trying to save fuel. So if we wanted to go to the moon here, that would be like a I don't know, maybe 24 hours, 36 hours. It would be pretty quick. It would cost us here is that we are much farther out of plane with the moon. In the challenge number 2, you are only, I think it was like 3 point some degrees out of plane. I think that's actually enough that it still requires an off-plane transfer, but maybe it doesn't. Nevertheless, in this challenge, we're definitely so far out of plane that we definitely want to do an off-plane transfer. So one way that you could complete challenge number 2, and I think probably what, if you're very new to Orbiter, probably what you would do is you could go around to the descending node. Okay, welcome to another Orbiter 2010 video. And in this video, I'm going to complete challenge number 3. This is one of the default scenarios that comes with Orbiter 2010. It's located in the 2010 subfolder, and then in there's a challenges subfolder. I already did challenge number 1 and challenge number 2, so now we're going to do number 3. Now this challenge, according to the little bit of text that you see when you click on a scenario, it's actually the same challenge as number 2, but the difference is quite a bit of extra fuel. So what we're going to do instead is we're going to warp time forward, and we're going to come around. We're going to wait until the moon comes all the way around to about here, and then what we'll do is we'll do our transfer at that point, because then by the time the moon gets over to this part of the line of nodes, we'll have adequate time to do a normal low energy transfer, or at least as low energy as is possible. So before we do anything at all, let's just warp time forward ahead. We're going to go at least this far. So let's go out to 10,000.